Okay, and welcome to Unit 4, Section 2, Solving Proportions with Cross Products. What? New way to do it. Cross products. Do it up. Alright, so in a proportion, the cross product is a product of the numerator of one ratio to the denominator of the other. Blah, blah, blah. Alright, so here's it all written out here. And what we have basically is a fancy way to do cross multiplying. That's what we're going to do. Except a lot of teachers, a lot of notebooks, and a lot of textbooks want you to do it this way. Look, see the blue and the blue and the red and the red. Like I snagged this. The blue and the blue gives you this and this. And now look, this looks like a fraction. That confuses more students with fractions and ratios than I've ever seen before. So we're going to do it a different way. We're going to do it our own way. It's exactly the same, but we're just going to write a little differently. Instead of writing your cross products on top of each other, what we're going to do is just write them next to each other. We're going to cross multiply. And what do we get here? So 2 times 27, that's going to be equal to, so that's equal to 54. That's going to be equal to 3k times 3. 3k times 3, you can multiply the 3 and 3 and get a 9, so we get 9k. Now look, this shows that they're equal. It's horizontal. I mean, this is a regular equation. This is much better. I don't know why everyone else doesn't do it this way, but for this example, you're going to get k equals 6, and you're done with that. It's that easy. Just cross multiply. How about the next one? If we cross multiply, what do we get? Well, this gets a little bit tricky. 7 times x, that equals 7x. That's not the tricky part, hopefully. Hopefully that's not the tricky part. 3 times 2x plus 5. Now, it's not 3 times 2x, it's 3 times 2x plus 5. And remember when Sully went through GEMDAS, he said that the top of a fraction is actually, that's a grouping symbol, like that whole top there. So when we write the cross products, we have to write 3 times parentheses 2x plus 5. Voila! And so that means we have a distributive property. We're going to get 6x plus 15 equals 7x. And now this is just we did this in Unit 3. You have variables on both sides. You get rid of the smaller one. That's the 6x. So we're going to subtract from each side. There's the line. Alright, they cancel. You get 15 equals 1x, and that's just x. So x in this case equals 15. We're all done. Alright, now this one looks a little bit more complicated. So one of the reasons I picked this problem is because, look, see this little negative right there? Oh, yeah. A lot of students get confused by what to do with that negative. So if you have a negative in front of a fraction, let me just scribble, 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 like negative 2/3 or negative x over 15, or in this case, negative 2 over w minus 10. Whenever you have a negative, just put it in the top. You can put it in the top or you can put it in the bottom, to tell you the truth. You just can't put it in both. So if there's a negative in front of a fraction, it can be in front, like it is here, or you can put it in the top. So negative 2/3 would be negative 2 over 3. Or you could put it in the bottom, but I'm just saying put it in the top. Here we would get a negative x over 15. You can do that. Alright, so clearing that up, going back here, I'm just going to rewrite this as 6 over 4 plus 2w equals negative 2. I'm going to put that right in the top so it's clear. Negative 2 over w minus 10. Now I can do my cross multiplying, and I'll make sure that nothing gets messed up by that. So 6 times, here's our cross multiplying, 6 times w minus 10. Because this is, look at that's called a binomial, you're going to learn that, but because there's two different terms there, you have to multiply the 6 times the whole thing. Use parentheses. That's the short version of that. All right, that is going to be equal to negative 2 times this whole quantity. So negative 2 times 4 plus 2w. Voila! We have a distributive property we can do on both sides. So we'll get negative 8 minus 4y. Oh, 4w. Mr. Kelly, learn your y's and your w's. Equals 6w minus 60 when you go to both. All right, now what? Smaller, we got variables on both sides. Smaller one is the negative 4. That's smaller than 6. So add 4w. That's the opposite to both sides. Draw a line. They cancel. So negative 8. Look, negative 8 comes down. They cancel. Equals 10w minus 60. All right, now what? We want to add 60 to both sides. Oop. So we get 52 equals 10W. And if I can scroll down a little bit here, we divide by 10, we get W equals 5.2. Oh my God, that's ugly. But that's the answer. Voila. So that's how you do those. That is difficult. Let's look at, you try these two. Tell you what, pause the video, you try these two, and we'll see how you do. Go.
It's time to play the music. It's time to light the light. It's time to meet the Muppet on the Muppet Show tonight. It's time to put on makeup. It's time to...
Okay, we're back. Did you pause the video? I hope so. So here's this problem here. I just set it up, and we'll see how we do with that. It's 4 times 3D plus 6 in parentheses. 7 plus 1. We will distribute both sides. Hopefully you did that. You get 12D plus 24 equals 7D plus 7. Hey, look at that. Smallest one. Alright, remember, variables on both sides. Choose the smaller one. They cancel out, so we get 5D plus 24. The equal sign's next. Remember, there's where that line is. So equals, and then a 7. So now we can subtract 24 from each side. How fun is that? So what is 7 minus 24? That's 17 with a negative. Alright, and that's equal to 5D. We divide both sides by 5, and the answer here is D equals negative 17 over 5. That, once again, Mr. Kelly's giving us the ugly problems, man. Alright, how about this one? Did you do, let's see, 11, let me change the color here. 11 times C minus 8. What do we have? Negative 2 times 11 minus 4C. Another distributive. Double distribute both sides of it here. So we have 11C minus 88 equals negative 22 plus 8C. Don't forget the plus. Okay, so we want to subtract 8C from both sides. Remember, we got variables on both sides. You want to get rid of the smaller one. So they're going to cancel out. What do we get? 11C minus 8C is 3C minus 88. The equal sign, negative 22. We want to add 88 to both sides. Two-step equation here. And we get 3C equals 66. Beautiful. Divide by 3, and C will equal 22. Perfect. Well, that was easy enough. So here's what I'm going to do. Right now I'm going to give you a little video from the local bomb holder power zone. I don't know if you've been there, but I mean there's like 2 aisles. We don't have that thing Ramstein has, but we have 2 aisles, and I found some ratios there, so check this out. Alright, here I am in the bomb holder power zone. Check this out. I have a Chinook here, a Chinook model. You build it. The scale is 1 to 72, which means the real Chinook is 72 times larger. Right here we have a patent tank. What do we got here? 1 to 35 scale. So when you build this, the real tank would be 35 times bigger. There's some real life application. Okay, so I'm in the power zone bomb holder. There's only like 2 aisles in the whole place, and I'm there. And I'm like, oh wow, check that out, scale right here. I'm gonna whip out my iPhone. I'm gonna do a little math lesson in the aisle. All the people around me, they just left. There was nobody left. That's the fastest way to clear out the power zone. Anyways, here's a scale drawing, and a scale drawing tells you how big. Look right here, scale. 1 inch is 12 feet. Well, let's look. Scale drawing, real life. So in this case, 1 inch is 12 feet in real life. So if you take your ruler and you measure across, then maybe you get like 5 inches. I'm just saying, for instance, I didn't measure it, then that would equal how many feet? Well, you could figure that out. It's cross-multiply thing. We just did that. You cross-multiply, you get 60 equals X, 60 feet. Voila, easy enough. Let's go to our next problem here, which is Ohio. It's the same type of thing when you have maps. 1 centimeter equals 85 kilometers. Well, I'm already going to set it up. All right, so on the map, we have real life, so I'll use RL. I don't know what else you want to use, but this is 1 centimeter is 85 kilometers in real life. So now you have to do the work. You have to I'll tell you in a second. But this is Ohio, by the way. My wife's from Ohio. I've got relatives in Ohio. And look, we have like Brust is from this area down here somewhere. And Sully's from up here. And they got the Bengals and they got the Browns. And they got Cedar Point. That's fun. You can go up there and play on the water. But anyways, I want you to figure out how far is it from Cincinnati to Cleveland. That'd be like driving from Brust's house to Sully's house. Roughly. I mean, that's roughly what it would be. What you have to do is go get your ruler, and you have to measure. Ooh, look at that. You have to measure straight line Cincinnati to Cleveland. Okay, so measure that out. Use centimeters because that's what the scale is in. And then solve the rest of this problem. Figure it out how many kilometers. Go. Did you get 4 centimeters? I mean, if I tried to make it 4 centimeters. If it's not, then what you need to do is blame Brust and Sully because they messed it up somehow. So 4 centimeters is what I got here. And you want to know how far is it? That'd be X kilometers. Well, cross multiply. So, let me show you 85 times 4. Well, I can do 85 times 2. What's 85 times 2? 80 times 2 is 160. It'd be 170 with the 5s. And then you need to double that. So, 170 doubled, 340. Equals 1 times x, which is 1x. So, x equals 340 kilometers. So, that is how you use a scale in a map to find the distance between 2 cities. Voila, easy enough. Let's do the last example. This is all for you. Ship model. The ship model kits sold at the hobby store have a scale of 1 to 600 feet. A completed model of the Queen Elizabeth is 1.6 feet long. Estimate the actual length. Go! Pause the video. Go!
It's time to play the music. It's time to light the light. It's time to meet the Muppet on the Muppet Show tonight.
All right, I covered her all up. Did you actually go and do this problem? Because if you didn't, your brain's not getting the repetition it needs to learn this stuff. So make sure you're actually doing it. I put some stupid music there so you'd go do it. All right, so here's the problem. We have real life and we have the scale model. So the way I wrote it down, we have scale model and real life, and you want to write that little unit ratio off to the side. We have 1 foot is to 600, and that's what they gave us right here in the problem. And what do we got? Equals 1.6 to x. You want to cross multiply. 1.6 times 600 is 960, and 1 times x is 1x. So you get x equals 960, but what did you forget? The units. Oh, Mr. Kelly got you there. Did you put the units down? 960 feet. Because it says estimate the actual length of the Queen Elizabeth II. Hey, that's it for this one. That one's pretty simple. Go ahead, do the problems. If you got questions, ask. And good luck on that mastery check. Remember, it's nice to be important. It's more important to be nice.